Hey everyone, what if I told you there's a single pattern that can solve a huge category of those tough coding interview questions, and not just solve them, but solve them in the most efficient way possible? Well, today, we're unlocking that exact pattern, the sliding window technique. I mean, think about it. You've seen these problems, right? Find the longest, or the shortest, or some optimal substring that fits a certain rule. Now, the brute force way, that can get super messy and really slow. So how do you do it elegantly? How do you solve it in just one pass? The answer, my friends, lies in mastering the sliding window. So what exactly is this secret weapon? At its heart, it's just an incredibly intuitive way to look at parts of a string or an array. You know, those contiguous, unbroken segments. Let's start with a really simple analogy. Picture the string you're working on, let's say it's PWQ, just laid out like a long ribbon right there in front of you. That's all it is, just a sequence of characters. Okay, now imagine you have two markers, or pointers. We're going to call them left and right. The piece of the ribbon that's between these two markers, that's our window. This little window is where all the action happens, and we're going to slide it all the way across the ribbon. Now, the real magic here isn't just having the window. It's all about how that window moves. It's this constant fluid dance of expansion and contraction. So, to put it a bit more formally, the sliding window technique is just an algorithm that uses these two pointers to define that contiguous section. We systematically grow it and then shrink it to find our answer, all while moving across the input only one time. And the whole process really just boils down to a simple four-step loop. First, you expand the window by inching that right pointer forward. Second, you check, is my window valid based on the problem's rules? Third, if it's not valid, you contract the window from the left side until it's valid again. And finally, you update whatever the best answer is that you've seen so far. That's it. That's the rhythm. Expand, check, contract, update. Now, the real key to all of this is this idea of an invariant. This is the heart of the logic for real. For any problem you're trying to solve, you just have to define one specific rule that the window has to follow. That rule is your invariant, and the entire algorithm is just built around keeping that rule true. So why are we doing all this? What's the big payoff? It's right here. O(n) time complexity. It is blazing fast. And the reason is, both the left and right pointers only ever move forward. They never go back. That means each element in your input is only visited at most twice. This single pass approach is what makes it so much better than any brute force solution. All right, theory is great and all, but let's actually see this thing in action with a classic coding interview problem. Here's one you've probably seen before. Find the length of the longest substring in a given string that doesn't have any repeating characters. This is a perfect textbook candidate for the sliding window. So for this problem, what's our rule? What's our invariant? It's super simple. The window must not contain any duplicate characters. The second we find a duplicate, boom, our window is invalid, and we know it's time to start shrinking it. Okay, let's trace this on the string PWPU. We start expanding, first P, then PW. Great, length is 2, the window's valid. But look at step 2. We add the next W, and our window becomes PWW. That's invalid. We have a duplicate, so we have to contract. We move the left pointer forward past the first W, which leaves our window as just W. Now we're valid again, and we keep expanding. We get W key, awesome, our new best length is 3. Then we hit W key wow, invalid again because of that W. So we contract from the left, leaving us with Q wow. We've hit the end of the string, and our final best answer is 3. See how that works? Oh, but hey, this pattern isn't just for uniqueness problems. Let's look at another classic, finding the smallest substring that contains all the characters of another target string. Now for this problem, the invariant kind of flips. We expand our window until it becomes valid, meaning until it has all the characters we need. Then, once it's valid, we start contracting from the left, trying to find the absolute smallest window we can that still follows the rule. It's the same expand and contract dance, but this time we try to shrink the window after it becomes valid. So, how does knowing this help you nail that interview? Well, it signals to the interviewer that you think about efficiency right from the start. You're not just trying to find any solution. You're engineering the optimal one. A brute force approach that just checks every single possible substring would be O(n) squared, maybe even O(n) cubed. The sliding window? O(n). In an interview, making that jump from a brute force idea to a linear time solution, that shows a really deep understanding of complexity. It's a massive difference, and it's what they're looking for. And of course, there are a few common traps you gotta watch out for. First, remember, a substring has to be contiguous, all in a row. Be really careful with your length calculation. It's almost always right minus left plus 1. Also, don't use a set if you need to count how many of each character you have. You'll want a hash map for that. And probably the most important one, always remember the core loop. If the window becomes invalid, you have to shrink it.
So, you've seen the theory, you get the mechanics, you've seen it in action. Now, the only thing left is to practice. You gotta build that muscle memory so you can spot this pattern instantly.
And here's a great place to start. These are all classic problems on LeetCode that are perfectly designed for the sliding window technique. We already talked about the first two, but there are other great variations, like finding substrings with at most k distinct characters or finding all the anagrams. Each one you solve will just make this pattern click even more. Look, at the end of the day, the sliding window isn't just the solution to one single problem. It's a powerful template. So the next time you see a problem asking for some optimal contiguous subarray or substring, you'll know exactly which tool to reach for. The only question left is, how many problems are you going to go solve with it?